This video is about central tendency. Central tendency is the estimate of the center of the distribution of values. You should know that this video is mostly for scale variables only, not for categorical variables. The only thing that you could use on categorical variables is the mode section of this video. In this video, we're going to talk about three measures of central tendency. That's the mean, median, and mode. They all make up central tendency for scale variables. So why do we need central tendency? Well, here we have two histograms that look very similar. They have the same shape, they're both bell-shaped, they're mound-shaped, but these two neighborhoods have different centers. So we'll look here, and the center is about where these dotted lines are, and for neighborhood 1 we have a center about 180, and for neighborhood 2 we have a center about 390. So that's a big difference. Even though they look very similar, the typical house for neighborhood 1 is around $180,000, and for neighborhood 2 is around $390,000. So these neighborhoods are very different. So we need central tendency to tell us where that typical value is, where the center of the data is. First, we're going to talk about the mean. Here we're going to specifically talk about the population mean, but there's also a sample mean. So mean is just an average, and here's the formula for the population mean. We're going to use a symbol. It's a Greek symbol called mu. It looks kind of like a squiggly M, but it's called mu, and that's the symbol we're going to use for the population mean. The xi means that we're just going to have each individual value, and we're going to sum them up. And then we're going to divide by the population size, which we're going to use a large N to denote that. And then here's the sample mean. It's similar to the population mean, but we're going to use different symbols. So here's the formula. So we're going to use what's called X bar for the sample mean. And then we're going to take each individual value, and we're going to sum it up and then divide by the sample size. And we're going to use a little lowercase n for sample size. Here's an example for a sample mean. And if you did a population mean, you would do the same thing, but probably with way more numbers. But we're just going to have a small sample here of size 3. So we're just going to add all the values up. So 3 plus 4, and then plus 5. Okay. And then we're going to divide by 3, which is the sample size. There was 3 numbers. And so 3 plus 4 plus 5, so that's 7, plus 5, that's 12, divided by 3, and that equals 4. So our sample mean for this example is 4. Now we're off to talk about the median. The median is just the middle number. But first you have to put the numbers in order. If you have an even sample size, you average the 2 middle numbers. So for an odd example, you would have 1 middle number and you won't have to worry about it. But when you do an example that has an even amount of numbers, an even sample size, then you have to average the 2 middle numbers out. So here's an example. The first sample 1, has 3 numbers in it, and so that's an odd example, and so we don't have to even out anything. And then the numbers are already in order here for us, so we don't have to put them in order. So 3, 4, and 5, that's already in order. So we're just going to go off here, and I like to mark out the sides until we get into the middle. And so our median for the first sample 1 is 4. Now sample 2 is a little bit more tricky. First off, it's out of order, so you need to put it in order. So 3 is the first number, okay, and then 4 is the second one. And then we're going to do 5. And then we're going to do 6. Alright, so now we're going to do the same thing. We're going to cross off each side and get in the middle, but now we're kind of stuck, right? So our two middle numbers are 4 and 5. So we're going to have to average those out. So 4 plus 5. And then divide by 2 because there's 2 of them. So that's 9 over 2, which equals 4.5. Okay, so our median for the sample 2 is 4.5. Now we're going to talk about the mode. The mode can also be used for categorical data, but the mean and the median is only for scale variable. It's the most frequent number. And here's a sample for mode. So here's our sample. So I'm going to write down all the numbers that we have and their frequency. So we're going to start out with the lowest one, which looks like 3. Okay, there's only one 3 it looks like. There's a 4. It looks like there's only one 4. There's a 5 and there's only one 5. There's a 6. And there's there's a 7. There's an 8. And then lastly, there's 3 9s. So our mode then is the 9. Now sometimes you'll have a couple of modes. So maybe if in the example we had 3 10s as well, then the modes would be 9 and 10. You can also not have a mode, so if all these frequencies were just 1, then there would be no mode. There's no one that has the most. There are 3 measures of central tendency, and you might ask, which one should we use? There's a mean, median, mode. Which one's the best to use? The most common one is the mean, and that's the most common one for scale variables. The mean uses the most information, and what I mean by that, it's averaging out each individual value. It's not just using one value. So the median is just using the middle number and it's crossing out all the other ones, and the mode is just the one with the most. But the mean uses all the values and averages them out. So it's good to use, and that's what we typically use because it's really good for inferential statistics. The inferential statistics that we do with means are more powerful than the ones that we use with medians. We don't really have inferential statistics for modes. So the mean is usually good if you can use it. But sometimes when you're describing your data, it's not always the best to use because it's not always in the middle. So here we have a negatively skewed histogram, a histogram with no skew, it's bell-shaped, and then we have a positively skewed histogram. So when it's skewed to the left, it's negatively skewed. The mean kind of gets pulled to the left-hand side, and it becomes lower than the median, and now it's more on the tail than it is in the middle. And then the mode kind of stays where it should be in the middle here, and in the peak. And then for the bell-shaped one, the mean, the median, the mode are all the same, and it's in the exact center where the peak is. And then if you have something that's positively skewed, the mean kind of gets pulled towards the tail again, and then the mean is greater than the median, and then the median is greater than the mode, and the mode still stays at that peak. So here's an example of when you might want to know the difference between the mean and the median, and I talked about this a little bit before. But when you have salaries, for example, and you're looking for a job and you look on the website and they report the mean salary, the mean might be affected by what are called these outliers over here. And these might be people who are in top management that make like millions of dollars or something. And so what happens is these outliers affect the mean because we're averaging out all the values. And because they're so big, they really pull the mean over towards the tail. And then the median, though, it's not really affected by these outliers because they just get crossed out on the ends. And so the median in this case would be a better representation of a typical employee. And the typical employees are the ones over here with the high frequencies. So if you're looking for a job, you want to make sure you're kind of looking at the median salary versus the mean salary.